Okay. Hello, students. All right. So today we are going to talk about 7.1 again, which is integration by parts. And this is day 2. And we are going to be doing definite integrals. Okay, so how to deal with definite integrals. So mainly today I'm going to talk mostly about notation because we already know how to do integration by parts. So here is our problem. Let's say we have the integral from 0 to 1 of tangent inverse x dx. Okay, so if we look at this problem here, one of the main reasons why we use integration by parts is because we don't know the antiderivative of some functions. For instance, tangent inverse. We don't know the antiderivative of tangent inverse, x. We do know its derivative, just not its antiderivative. So that is one of the main reasons why we use integration by parts, because it helps us go around that situation. All right, so what I would do is I would set up my u and my dv. So here's my u and my dv. And clearly, my u has to be tangent inverse x, because if I put that in dv, I won't know the antiderivative of it. So what is du? It is equal to 1 over 1 plus x squared dx, right? Okay, and so now dv, what is left for my dv? It is dx. And so what is v then? That is x. Okay, so now when I use my integration by parts formula, uv minus the integral of v du, this is going to be equal to uv, I'll put the x first for notation purposes. Let's leave a space for a second, minus the integral of v du. So I'm going to have x all over 1 plus x squared dx, like so. Now, if this is a definite integral, therefore, this needs to be a definite integral. We cannot change the form that we have. Okay. Also, this part has already been integrated. So we're going to put an evaluation bar, 0 to 1. Okay. That needs to be evaluated. Okay. At this point, we can evaluate this and continue integrating this however we choose, or we can hold on to this expression, integrate this, find its antiderivative, and then evaluate it all together. Okay, I'm going to do it all at once just because I like to do it all at once. But the important thing is that if this is if this is a definite integral, this integral needs to be definite, and this expression needs to have an evaluation bar because it's already been integrated. Okay, so now we're going to move on. Bring this down. Tangent inverse x from 0 to 1. And when I look at this, I go, okay, this is not an integration by parts situation. This is a u substitution situation. This is us undoing the chain rule. I already used u in this problem, so I'll use w. Okay, so I'll say w is equal to 1 plus x squared. So then dw is equal to 2x dx. And then therefore, dw divided by 2 is equal to x dx. Now, since we've done w, that means that we're going to need to change our limits of integration because that is in terms of x's. So therefore, when w is equal to 1, when x is equal to 1, w is equal to 2. When x is equal to 0, w is equal to 1. Okay, so now this is going to be minus the integral of from 1 to 2, and I'm going to pull out this 1/2. This is dw, so right here I have dw, and this is w. So this is going to be 1 over w dw, like so. All right, and now this is going to be x tangent inverse x from 0 to 1 minus, and this is going to be 1/2 natural log absolute value of w from 1 to 2. And then you would just integrate. So if I put in 1, tangent inverse of 1 minus 0, tangent inverse of 0, minus 1/2 natural log of 2 minus natural log of 1. Like so. Oh, sorry, you didn't see that. Okay, that's me evaluating. All right, so now this is going to be, what is tangent inverse of 1? If you know your unit circle, that would be pi over 4 minus tangent inverse of 0. Well, it doesn't matter. That's 0. So that's going to be 0 minus 1/2. And this is going to be 0. So this is natural log of 2, like so. And you can further simplify as pi over 4 minus natural log, 1/2 natural log of 2, which, by the way, is equivalent to pi over 4 minus natural log square root of 2. Either one of those works. And then highlight. And that's the end. Happy days. Okay, so we're doing integration by parts. Here we also ended up using u substitution, except we used w, but it's the same idea. Okay, the most important thing is that you're paying attention to the notation. That we did the evaluation bar, okay, for the part that's integrated. We kept this as a definite integral. If we did use substitution, we make sure that we follow the rules for notation when it comes to definite integrals for u substitution. And there you have it. That's the answer.